just if people could rename with your name, congregation, town, and state, that's much appreciated, and we'll get started. So welcome everybody. Jewish Climate Action Network presents. I wanted to introduce by just laying out the decarbonization curriculum that we have, the recurring workshops, a cycle of 3. And it's highly recommended that you or a representative, another representative from your congregation or community attend each of these. So it could be 3 different people, but attending these is a good thing for organizing in your congregation as a climate activist. So one of them is running a decarbonizers program, and that's exactly what I just mentioned. Scott Kadish, who's on this call, just did for his group. And this is typically for the households in your congregation. In other words, your congregational members. It is a peer-to-peer program to motivate and influence your fellow congregants. So it's a training program in how to run that program. That's our single most influential, most popular, most successful program at getting decarbonization to happen. We also have a program that we've been running for years, a workshop that we've been running for years, and now we've said it should fit into the current 7-year plan. And that is now on hiatus because next month in July, our featured program will be all about doing climate plans from a professional who does them all the time. So that's exciting. So please look for that. It's going to be announced shortly, right, Thea?
Yes.
Great. And then our third regular workshop is benchmarking, meaning calculating the carbon footprint of your synagogue facility, of a building, a house of worship facility. And that program happens to be coming up tomorrow. So if you might be interested, there are still slots available. And Thea, I don't know if we're able to put into the chat the link for that. It might take, would you be able to do that?
I'll figure it out.
Thank you very much. So if you're interested, there's an opening tomorrow at noon for that. Also, please feel free to jot down this email address if all things decarbonizing relating to JCAN, you're welcome to be in touch. That would be wonderful. And I'll make a pitch that we can use funds. We are mostly virtually all volunteer organization, and funds can be very helpful. We very much appreciate any donations. Tonight's program, I'm very excited about. Rachel and Audrey are leaders in the field, have been for years, and they're no longer brand new approaches, but the thinking that they have, the engineering that they've formulated is fascinating, and it is leading the field. And if you didn't see it at the beginning, here's the quick bios. And those that have just come in, I'll just say it one more time, please rename with your name, your congregation or community, your town, and your state. And just as a frame, I'm going to say, and by the way, I'm Fred Davis. I'm the president of JCAN, and I welcome everyone here tonight. And as a frame, I want to put it this way. You may be thinking about your own house, your own roof, your attic, your heating system, and that's fine. There's no way not to do that. So that's fine. We will get into as we get into the Q&A later. I'm sure those questions will come up, but I will encourage you to think beyond your own household and think about your community, your congregation, your synagogue, and your neighbors. And as you'll see, Audrey will be our first speaker. The engineering that she's talking about is necessarily communal, as you'll see. But the essential questions for us are we moving fast enough? And what can we do? What can we do beyond our own household? What can we do to encourage those in our community to move fast enough? The residential sector must decarbonize. There is no path to climate goals that doesn't include household. In Massachusetts, for instance, over 60% of all carbon in buildings comes from households. There's no path without us. So please think about your role as an organizer as you go back to, as you take what you learned tonight and back to your community. I hope that comes into our discussion. Last but not least, it is not beyond you. Thank you very much. And I'll take my slides down, and Audrey is up first. Thank you very much, Audrey, and thank you in advance, Rachel.
Thank you, Fred, so much. I am now going to share screen, hopefully. So hopefully you are seeing the right presentation and not my ordering on eBay. So HEET is a nonprofit. We take funding from foundations, donors, and sometimes the government. We don't take funding from industry, and that's so that, whether gas or geothermals, and that's so you can trust us, hopefully. We work with everybody. This is a photo of one of our charrettes, which is our stakeholder meetings. At this meeting, there's some gas utility executives, some gas union leaders, a guy who did a 30-day hunger strike against gas peaker plants, some community activists, the guy who came up with the term gas is the clean bridge fuel. In other words, we work with everybody. And we do that in order to learn from everybody and try to find, try to surface the problems and solve for them before they happen. And we work in the safe space of science and data so that hopefully everybody can trust us. So currently in this moment, a lot of us are loving heat pumps because they provide both heating and cooling, and they're a method of reducing our emissions by moving to electricity in an extraordinarily efficient way. So last year, heat pumps actually began to sell more than gas furnaces, which is thrilling. However, our gas utilities here in Massachusetts are meanwhile still mandated to replace a lot of gas infrastructure for safety and for emissions. And they're installing instead new gas pipes that will last for decades. This is a map of the utility reported sites over the next 5 years in the Boston area. So the problem with this is that overall, over the next, over the 20-year program of doing these pipe replacements, they will be spending more money than the gas infrastructure in the ground is currently worth in its depreciated state, right? And the cost of this infrastructure is amortized over decades and across all gas customers. So our kids and our grandkids are going to have to pay for this stuff. And it's in totally running counter to our state's net zero emissions mandates. So this is crazy, but the gas utilities have to do it. They're told to do it by the state. And meanwhile, we have those gas customers who are moving one by one to air source heat pumps, right? And each one of them getting off the gas system does not in any way reduce the gas system's size or operations costs, right? So there's fewer and fewer customers sharing the costs of maintaining that gas system, meaning each person getting off the gas system is increasing the cost for everybody else. At some point, there's going to be an inflection point hit where gas is going to become more expensive to heat with than air source heat pumps. At that point, there's going to be a rush to get off. The only people left in the end will be those who are, low income and renters. And that's not, they're going to be stuck with just shouldering skyrocketing gas bills. That's not the way we want to transition. And the Germans actually call this the last grandma problem, where they imagine one last grandma, unlike the entire national grid system, trying to pay for the operations and maintenance of that gas system. That would not be a great thing. So HEET sort of figured out some of these problems back in 2017. And we began to pitch to gas utilities the idea of instead of installing new gas infrastructure, why not try installing networked ground source heat pumps? I mean, how awesome would that be? I want ground source, but I can't afford to put boreholes in my backyard. If the gas utilities did it, they could do it in the right of way of the street. They have the financing, they have customers, they have the expertise of pumping thermal energy through the ground, through pipes in the ground. They'd be great at this. And the system that we suggested has very shallow boreholes. So they're just a few hundred feet deep. It's a closed loop system, which means it's filled only with water once. And in the building's heat pumps, pull the temperature off, heating or cooling that building in particular needs. So just want to restate, this is not, even though we use the word geothermal, it's not going down so far that it's into lava. It's not creating electricity. It's not creating steam. It's not a single building installation of ground source heat pumps, but instead it's networked together. And the reason why that's important, I'll get back to that in a second. One of the reasons why it's important is because then the gas utilities can transition whole streets at a time. And getting, economies of scale, everybody in a neighborhood will maintaining that incredibly important ratio of gas customers or thermal and gas customers to infrastructure so that you don't get those skyrocketing energy bills and that last grandma. The other outcomes would be safer because it wouldn't have gas in the pipes, right? We all remember Merrimack Valley gas disaster. The energy bills, the heating bills are actually predicted to be lower this way because currently your gas bill, it's about half of it is just paying for the fuel and half of it's paying for the operations and maintenance. And so if we go to this system and the gas utilities install it and they amortize it in the same way that they normally do, you have the operations and maintenance, but that fuel cost, the gas, it's gone away, right? So you only have a minimal amount of electricity that you're paying for because this is the most efficient system known for delivering heating and cooling. And that's why Applied Economics Clinic predicted that the energy bills, the heating bills in Massachusetts should be lower over time than the gas. Also, so in order to reduce our emissions from the building sector, we have to move all of our buildings' energy needs to electricity and then produce that electricity with renewables, right? That's going to be a huge burden for the electric grid, especially during the winter, when we normally get most of our energy needs from gas and other fossil fuels. So the efficiency with which we move to electricity is critically important because it will reduce the burden on the electric grid. This is a paper that was that came out of Harvard that shows the different methods with which we could move to electricity, starting with electric baseboard up at the top, which of course would be the most inefficient method. It's still more efficient than gas, but it is the most inefficient electric method. And moving on down, and networked geothermal is actually the most efficient system. And that COP of 6, in case anybody's interested, and COP means one energy unit goes in and 6 energy units come out. So you move 6 units of energy into or out of your building for every 1 unit of energy you use. And that comes from an Excel energy case study of Colorado Mesa University, which will be out soon, where they look at the actual energy use. And that's the COP they're finding. It's quite amazing. It is incredible. Anyway, it also would be very equitable because you're going straight down the street, getting helping everybody to transition to renewables, and the workforce can also transition because the pipes are exactly the same, right? So they already know how to operate and maintain them. They already know how to install them. And that's why both the pipe fitters nationally, as well as the steel workers in Massachusetts support this idea. And finally, of course, the emissions would be lower. So we did a study with Borough Happold. They found that any building connected to the system, as opposed to gas, would reduce its emissions by 60% immediately. And that those emissions, of course, would decline over time as our electric grid move towards more and more renewables. So luckily, the gas utilities are actually installing this. Last Monday was the groundbreaking for the first installation with Eversource. It's in Framingham. There's a fire station, part of a school, a few businesses, and a lot of homes. I think it's over 150 units in total, businesses and homes. The installation should be complete this year before the winter season. And National Grid has 4 different installations approved. The first site is selected in Lowell. And in those sites, they're going to actually be taking all the gas appliances out of the buildings and replacing them with electric appliances. So this is a gas utility that will be electrifying. It's sort of amazing. So the idea is catching on. There are now feasibility studies proposed in all sorts of different states or proposed installations. Over 100 proposed installations in California alone, which is just like breathtaking. There's some legislation that's been passed in New York, that Utility Thermal Network and Jobs Act. It was passed in just 2 months because it was pushed by the trifecta of gas utilities, unions, and environmentalists. Such an unusual situation. There's a lot of more proposed legislation, including in Massachusetts, the future of clean heat, which would do all sorts of things to allow gas utilities the opportunity to evolve without actually, if they screw up, right? But it would give them the opportunity to evolve. There's a lot of supportive advocates working nationally to push this further. And strangely, and this is one of the strangest things, HEET's been somewhat pushing against gas utilities for almost a decade now. And so it's very strange for me to say that there's actually a gas utility coalition that has formed. There's 14 of them that are in the coalition last time I heard. This is more. These are all the utilities also that have contacted us, including at this point, Gas Technology Institute, which is the research arm of the gas industry. They are like doing outreach for us about this idea. It's sort of just mind-blowing. And in terms of what might interest you, in terms of either community-based or your building or your synagogue or anything, this is the Inflation Reduction Act. You can get up to 50% tax credit if you do, if the installation goes with fair labor practices, if it's an EJ area, and if it's with US made materials. And there's also the Energy Infrastructure Reinvestment Act, which in terms of gas utilities or municipalities or other bigger installations, you can get very low interest rate loans from the loan program office to do this work, and then use the savings in terms of that decreased interest rate to move it towards customer building retrofits, which is incredible. So what I hope is that all of these potential fossil fuel installations move towards networked geothermal, so that each of these can become a seed site that can interconnect over time together like Lego blocks, growing out to become the infrastructure that our children and our grandchildren use and need and can legally use in this state with its net zero emissions mandate. Supplying safer and less cost energy, and doing it with equity for all. And that's it. Thank you.
Wonderful. Thank you so much, Audrey. Rachel, do you want to go? Do you want to have a few questions from folks for clarification if they have them before Audrey gets off the screen?
That's up to you. Audrey, would you like to take a couple questions now or take questions at the end?
Whatever anybody wants.
Let's take two. If people have particularly questions that are particularly for clarification purposes, just make sure you understand this. Well, we use the term radical concept here in residential heating. Okay, Monica says very inspiring. Scott is very proud that he just moved to Framingham.
Alan Sherman has a question, and
Go for it.
I do, thank you. So Audrey, this was very enlightening. Thank you so much for the presentation. My question is, if we were to switch our homes and our synagogues to network geothermal, is there a way to leverage the existing infrastructure in the building as far as the duct work, if you have forced hot air, or the pipes if you have forced hot water, along the same lines that we were all able to switch to LED light bulbs because the LED bulb makers were smart enough to make them fit our incandescent fixtures?
By the way,
So-
not always. I happen to be the lighting expert in the room.
Ah,
The LED still does not always just screw into the sockets, but I get the concept, Audrey. And this is a good enough question for clarification. And then after this, we'll go to Rachel. Thank you.
thanks, Fred.
So first off, I worked in HEET worked in Temple Imuna a long time ago. So it's a lovely building. Yes, every building will be different. But in general, you should be able to use the same radiators, the same vents, et cetera. You're going to have to add some insulation. If you have steam, you probably, in order to maintain the efficiency of the system, going to have to replace the distribution system in your building, right? Because, and that's understandable because steam's a very old technology and you probably should replace it either way. And I can, as I'm, steam is actually oversized. It's meant to, became popular during the Spanish influenza. So it intended to work with your windows open so that you get constant ventilation. So steam is something that should go in any case, but the other systems should, with some changes, and again, every building will be different, work, just interconnect. You put the heat pump in, it connects easily. It's a water source system. It connects easily to your hydronic system, your radiators, or it can be easily connect water to air to your vents. You might have to do some changes, including maybe electric panel upgrades.
Mhm. Thank you.
Great. Is it okay, folks, if we hold on further questions? Because that covered a lot. In other words, will it fit my building, whether it's hydronic or air? That a lot of people are going to have that kind of question. So that covers a lot just with that quick answer. But can we go to Rachel and we'll come back for more questions for Audrey afterwards?
Sure, I'm happy to do that.
Thank you.
Okay, is everybody seeing my full screen?
Looks
All right,
Yes.
thanks, Audrey. It's great to be with you all. I think I presented to JCAN a couple of years ago, so it's great to be back. For those who aren't familiar with Byggmeister or don't remember the few words that Fred put up at the beginning of the screen, at the beginning of the presentation, Byggmeister is a renovation and retrofit contractor working on single family homes and some small multifamily, but we only work on existing homes. We don't do new construction. And our niche or sweet spot are projects that combine functional and livability improvements to homes to performance improvements. So we're moving now from Audrey was talking about the system, the neighborhood, the network. We're turning now to talk about your home and what you can do right now to turn your home from a climate liability into a climate solution. Fred started out by saying that there is no path to achieving our climate goals without addressing the residential sector. I couldn't agree. That's absolutely the case. According to the 2020 Massachusetts Greenhouse Gas Inventory, which breaks out electricity emissions as their own sector, residential emissions are 20% of our emissions in the state. If you can slice and dice it differently, especially if electricity is apportioned out to end uses rather than its own sector, but it's a big proportion of our overall emissions, and we really need to address those. As Fred said, there's no path to achieving our goals without that. As I'm sure everyone on this call knows, Massachusetts has a climate action plan. There's an interim way along that plan that commits us to cutting emissions in half from the residential sector by 2030. And the reason I've included this table is because it shows that, you know, from the time we started doing this back in the late 2000s until 2010, we made very little progress. We cut emissions by a mere 20%. And then in the last decade, to get to that 50% reduction, we've got to do most of the work. And now it's, of course, 2023. So we've got to cut 30% more from this sector in order to achieve that 50% reduction. And we only have now 6.5 years to do it. So we've got a lot to do. Every sector has its challenges. The residential sector is unique in that our emissions are spread across so many buildings. There are 2.71 million residential buildings in the Commonwealth. And if you look at this pie chart on the left, you can see that single family and small multifamily together account for about 2/3 of building emissions. Of building square footage. So that's a lot of residential square footage, a lot of small buildings that we need to fix. And a lot of those buildings, if you look at the chart on the right, they're old buildings. You know, most of the homes are more than 40 years old. Older homes emit more carbon. Typically, they're also a lot harder to fix. So we've really got our work cut out for us. We have a lot of homes to decarbonize in a really short period of time. What do? Audrey was coming at it from one angle. Obviously, it's addressing not just the residential sector, but buildings across the board. But what I'm going to talk about for the rest of my time with you is to give you some ideas about what you can do with your home right now. And of course, you can also, I'm sure we'll talk about this at the end, come back to how all of us here can get involved in helping HEET and other organizations that are looking at networked and neighborhood and sort of more communal solutions. But there's always this question, all of us, what do we do right now in our own homes? So I'm going to share, if I can advance the slides, I'm going to share some case studies with you of projects that Byggmeister has done. And then hopefully that will give you some idea of some of the things that you could think about doing for your own home. So I'm starting here. This is a 2014 deep energy retrofit that we did. I'm starting here. This is the way we don't really do it anymore. And I'm going to tell you a little bit about what we did and why we no longer do it this way. So back in the 2010s and late 2000s, we and other retrofit contractors thought that the best way to decarbonize homes, sort of the gold standard of emissions reduction, was the deep energy retrofit, which is taking off the siding, the roofing, taking out the windows, adding thick layers of insulation to the outside of houses, taking all those windows off and replacing them with triple pane windows, and then electrifying. And this project is a really, probably the best example that Byggmeister ever did of this approach. And it was really a near perfect candidate for a deep energy retrofit. Many of the systems were near the end of their useful life. There was significant deferred maintenance that needed to be redressed regardless. The building form was relatively simple, which makes the prospect of superinsulating from the outside easier than it is on homes with more complex geometry. You can see it had a very large south-facing roof that made it a good candidate for solar panels as well. So it was a really good candidate for superinsulation, electrification, solar, the sort of the full package. Like all of our projects, this project had a remodeling scope. or like most of our projects, I should say, not all, renovating the kitchen, the baths. We did a small addition, finishes were upgraded throughout. Then on the envelope side, we did that super insulated and super airtight building shell, changed, electrified the whole house with they have a wood stove for resilience and backup heat. And here's some couple of in progress photos. You can just highlighting, you may have seen photos like this before, the DER approach where you sort of cut off the roof overhangs of the house so we can wrap the insulation on the walls up and over the roof. You see up in the top left photo some that we're rebuilding those roof overhangs. And then let's see, what else can I say about this? We also simplified the building form. If I go back a couple of slides, you see it was a Dutch colonial and we turned it into a regular colonial. But in any event, coupled with the high performance windows, the air sealing that we did, is a really tight building enclosure, very well insulated, very comfortable with very low heat loss. And the results are really dramatic. Annual energy use went down, was cut by about 75%. Carbon emissions went down by 60%. I included here what the average home in Massachusetts, their annual energy use consumption, and it's 88 million BTUs a year for you nerds out there. This is from the 2020 Residential Energy Consumption Survey, or REX. You can Google it. Not all the data is out for that survey, but there's a lot of it, and they stopped doing state by state breakdowns during the Trump administration, but they're back to doing that again. So there were a couple of REX cycles that did not have any state breakdown data, but now they do. So anyway, I was able to incorporate that. So this house is using a lot less, like a third, of, or 2/3 less than what the average home in Massachusetts is using. And in its first 8 years of operation, those solar panels have produced 40% more energy than the house consumed. So they're a net positive home, and they built up credit with the utility. This project is extraordinarily successful, not just because it's so low energy, but it's also incredibly comfortable. It's just a better house. It's more resilient. And so you might think that we went on from this project to do many more deep energy retrofits, but that's not the case. In fact, we did just one more after this. That was in 2017, and that was the last one. So why? Well, one of the things, so a few reasons why we stopped, why we no longer do deep energy retrofits and no longer really recommend this as sort of the most sensible or the best approach for most homes to decarbonize. The first is that what we have found is that they're incredibly high cost. And when the incentives, there was a time back in the late 2000s and early 2010s to the like 2015 or so, where there were lots of utility incentives for super insulation. Once those went away, it was really hard to convince people to spend money on this. And we found that even if you don't factor in the new roof or the new siding, you're talking 2 times more, sometimes 3 times more the cost of if you're just insulating within the cavities. Waste, in some cases, roofs have a usable life, a asphalt roof of maybe 20, 25 years, but that's often not the case with some older siding, with some windows that can be refurbished and you can add storage to them. It's not the same as having a triple pane window, but we found ourselves in a situation of, to do these projects, we're throwing away, recommending that people throw away material that has lots of usable life left in it. Also, as Audrey discussed, we became clear within the past 10 years or so that we need to electrify everything in order to achieve our climate reduction goals, that using less energy and decarbonizing the grid is not enough. We also need to change all of our end uses of energy as much as we possibly can, but especially buildings, to electricity. And then the last reason, I guess, why we stopped doing deep energy retrofits is because of the upfront carbon emissions associated with doing this work, particularly with foam insulations, which are high emitting materials. that's the material that we had been using for most of these projects. And given the short time period that we know we have to avoid a climate tipping point, we believe we need to be really careful about how much carbon we emit now to save carbon later. There are newer options. Some of you may be familiar with them, wood fiber-based panelized insulation that you can add to the outside of the home that don't emit carbon or are considered carbon storing. But these materials are even more expensive than foam panels. So the new approach that we've been doing over the last, 6-7 years is what we call a moderate retrofit approach. That's where we insulate and air seal as best as we can within the existing cavities, the existing wall cavities, the underside of the roof. We no longer bother to add insulation to the outside of homes in most cases, and then we electrify them. So this particular project had a remodeling scope focused on the first floor, kitchen, dining room, living room, turned a powder room into a full bathroom, added a deck. Insulated as best we could from the inside. We insulated the foundation walls, the above grade walls were, those walls were mostly empty, insulated all of those. There had been some fiberglass bats on the attic floor. We moved the thermal boundary to the roof line and changed out about 40% of the windows. The rest of the windows still are single pane with storms. And with those measures, as well as some targeted air sealing, we were able to cut the air leakage of this home in half. On the mechanical side, we took out their gas boiler and water heater, got rid of window AC, and installed a ducted mini split, one in the attic to serve the second floor and one in the basement to serve the first floor, and a heat pump water heater. So here are some photos of this project. You can see in the top left, the gas boiler, which we think was installed in like 1955. And just behind it, an almost as old, if not as old, water heater that was so old our plumber even took a picture of it. On the right, I'm not sure why we included this picture of me talking to the homeowner in the attic, maybe just because of all the stuff they had up there. And that was, so in addition to the fact that we wanted to use it for mechanical equipment, putting thermal boundary at the attic floor was not really a good option for this house. And so you can see in the right, the insulation at the roof line with the ducted heat pump below that. This is the only, I've got one more project I think to show after this. This is the only one. I just wanted to include a photo of the renovation work to make the point that for these clients, like many of the people we work with, the sort of the primary reason or the driver why they get in touch with us, many times it's about performance, but a lot of times it's as much, if not more, about functionality and livability and making their homes work better for them. And then we use the renovation as an opportunity to also improve performance. Again, it's not like we're dragging people kicking and screaming, but it's the renovation work is often why people reach out to us. More often than not, why people get in touch is because they can no longer stand their kitchen like that. So let's look at the impact. This was a house that had a long way to go. You could see from that mechanical equipment, my description of the envelope, that very little had been done to that for a couple of generations. And so when you have farther to go, you have more energy to save. And with these, pretty moderate envelope measures, as well as the mechanical upgrades, we cut energy use by 80%. This house is now using half what the average house in Massachusetts, and similarly, really dramatic reductions in carbon emissions. Could we have done better with this house if we'd taken off the roof and the siding and replaced all the windows? Sure. Would it have been worth it? I'm not so sure. I'm going to share one other example. Just to give you, this is a 2020 project where we did a moderate partial retrofit. So not whole, we weren't treating the entire building fell. We're only working on part of the building and then electrifying, just to show that you don't have to treat the whole house to make a significant impact. So for this particular project, again, we had some remodeling scope focused this time also on the first floor. The real opportunity for envelope upgrades was at the roof line. The walls had been insulated, that's below grade walls mostly, as well as the above grade walls. But that the third floor, which had had a dormer put on, I'm not sure exactly what year, was really not insulated well. And so the opportunity was really up on that at the roof line. So I'll show you on the next slide what that work looked, what we did up there. And then this house had, interestingly, a combination of oil and gas. They had an older oil system that was heating the original part of the house. And then in addition, prior owners had done off the back of the house, I can't remember again what year, and added the dormer on the third floor, installed a gas system to heat that. And there was ducted AC. So we took all that out and did a combination of ducted and ductless heat pumps, a heat pump water heater. They had some existing solar, so we didn't have anything to do with that. All right, up on that third floor, so we took out on the top left, they had an existing hydro air system, and we dense packed with cellulose behind that pre-existing plywood. You can see on the bottom left what they had for insulation up there. It's like a 1 inch maybe batt that was in the ceiling throughout the entire second floor. So we removed that and we dense packed the finished slopes of that third floor and then installed loose fill cellulose in the flat section of the attic. And the photo on the right just shows looking at the new ducted air, the air handler that's on the third floor that's serving the bedrooms on the second floor. There are some ductless units in the third floor to serve that space. With this like sort of limited scope on the envelope, we were still able to make really significant reductions in energy use as well as carbon emissions. So the mechanical changeover is driving a lot of that. Emissions going down more than half. This house, you'll note, is still using more than the average Massachusetts dwelling. That is true for many of the homes we work on. But you can see how much it was using before the project. And so, again, we'd like to see it go down further, but we still made a significant impact with that partial envelope work. All right. Here's the single family home decarbonization. I call it the playbook. I don't know if it's framework, whatever. This is thinking about what you can do with your home right now while you advocate for networked geothermal on the side. So there are 3 pillars. You all probably know what these are. It's efficiency, insulation and air sealing. It's electrification, getting your home off of fossil fuels, and then switching to renewables. You don't have to have a good solar aperture to be part of the renewable revolution. You can sign up for 100% green power. But how you implement this playbook, where you focus, is going to depend on your building and your opportunities. You might live in a house that's a good candidate for a deep energy retrofit. I would say probably not. I think I've encountered very few of those in all the years that I've been doing this. You have some smaller set of opportunities to take advantage of, some that might make sense now, some that might make sense 5 years from now, depending on the age and condition of your systems and your equipment. And so you do what you can when the time is right. I'd say in general, what's changed for Byggmeister is that we're investing more in electrification than we used to. We used to invest, as you saw from the 2014 project, a lot more in that first pillar of building efficiency before we would electrify. And I would say what's changed is we're not insisting that we bring a home up to kind of the standards of high performance new construction before we electrify, because we really need to move all of our end uses to energy to electrification. Although keeping in mind Audrey's point about the grid, we really do need to pay attention to strain on the grid, which is why the quicker we can move to more efficient uses of electricity, the better. I'm almost tempted to say that this home by home approach of air source heat pumps is like a bridge solution. Not that I want to I don't know, that phrase has been tainted because of its use by gas, but nevertheless, I do envision a future where we're not looking at building by building solutions for mechanicals, but are looking at a network solution. I've gone on too long, so I'm going to close quickly. Decarbonization is an all or nothing. Focus on doing the next best thing for your house. You don't have to super insulate to achieve substantial reductions. You just need to focus. Everything you do to your home, remodeling project, upgrade to windows to systems is an opportunity. And if we were all think opportunistically and plan ahead so we could take advantage of the opportunities before they pass us by, we might have a chance of meeting our goals. And I've got I think you guys will share this. I've got my contact information on my last slide. So if people have questions afterwards, they can get in touch with me.
Wonderful, wonderful, wonderful. I'd encourage everyone to come back to screen. In other words, share your video if you don't mind. We'll get into Q&A, and I'll kick it off if I can. Rachel, you're talking about site decarbonization, and you showed the numbers of the ending where the reduction in carbon. But once a home is site decarbonized, in other words, there's no gas or oil heating or cooking, what happens over time to that home's carbon footprint?
Oh, Fred, what a good question. So as the grid gets greener, the carbon footprint of the home goes down. And I think you're asking that question, I think, to make the point that fossil fuels are never going to get any better than they currently are. And so that the only way to get to zero is to get to carbon neutrality is to electrify, and then to work on getting the grid to 100% renewable.
Great. And Audrey, I don't know if you have any comments about the grid getting greener?
No, it's a lovely, I'm a lazy person. I'd much rather have my house electrified and then not have to worry about it anymore. It's just, you remember that old commercial of like, my stove is being cleaned while I do whatever. It happens while you're not paying attention. It's a lovely way of doing this. And I'd also like to just say that what I'm talking about is plausible. Rachel's doing the hard work of actually making stuff happen in buildings. And
I don't know if you're not doing the hard work of making things happen. It's just at a different scale. No.
Who knows if it'll, fingers crossed it'll work, but like working building by building, that's a hard thing.
Well, we have to go at it from both directions. And yes. I think that's why it's great that you have us together, have us together, Fred, because it's not either or.
Mm-hmm.
I hope people can see that here, and I encourage questions. There's no such thing as a dumb question. And we've already had a couple of good ones, and let's see if we can get to them. Let's see a
hand up, but
Sam Getcher has a question.
Hey there. Thanks both of you for coming to present all this stuff. Rachel, I've got a question for you. I live in Somerville, and we just adopted some specialized code that I haven't had time to review yet. But I'm assuming that it increases some level of standard for renovations. Is the type of stuff that you all do already at that level? Or is it something that even folks like you are going to have to like push farther to get to the new requirements? And it's new, so, if anybody's reviewed.
So it's a really good question, Sam. And one of the things that our team is trying to really understand is there's sort of now 3 new codes. There's the IECC 20, is it 23 or 21? I think it's 23 base code, which a lot of our renovation work reverts to. There's the stretch code that applies for residential work. It applies when you're doing over a certain percentage of renovation or addition to the existing building. And then there's the opt-in, the specialized opt-in code. And some of them are coming online at different times. I think I could be wrong about this, that the opt-in code doesn't have a lot to do, doesn't change things very much for the kind of work we're doing at for residential renovations. That the bigger work is happening at the base code as well as the stretch code, which kicks in for large renovations and additions. I think over 1,000 square feet or over a certain percentage of the existing structure. So in general, there's people who do high performance work are trying to figure out what all of this is about and how to integrate it into our practices. And there are going to be times where we're going to be advocating for things telling our clients things that they need to do that they didn't need to do 2 or 3 months ago. And, in a way, I think that'll make our jobs easier.
Yeah. Thanks.
Not everybody is in Massachusetts, and just to let folks know, the specialized opt-in stretch code has now been adopted by, I think, as of last week, 17 communities. And all green communities, that's an official term in Massachusetts, a green community are now part of the opt-in code, but the specialized is so far 17, or maybe it's up to 20 now, but it has to go town meeting has.
It's so confusing. All these different names. It's really hard to keep up. We'll probably catch up in another 6 months.
It was to be called the net zero code. And it's close. The opt-in stretch code is very close to actually net zero. Okay, next question. And Tia, are you calling people? Because I can't see all hands.
Yes, Janet Green has a hand up. Janet, you're muted.
Oh, okay. Actually, someone asked that same question in the chat about the difference between. I have just a straight electric cooktop, so the difference between that and an induction cooktop.
Audrey, haven't you done a lot of stuff with cooking? Do you want to take this one?
Yeah, and you can correct me if you know something different. So we were some of the people who started the gas, the chemistry of gas studies that have made a fair amount of news. But in terms of induction versus electric, I've heard that it depends on what kind of cooking you're doing. So, and this is just one research study, so it could be, who knows. But if you are doing longer term slow cooking, one is better. If you're doing fast cooking, the other is better. But I don't think it makes that much of a difference between an electric conventional stove and an induction stove. But Rachel, you might know much more.
I guess it sort of depends on what differences you're trying to get at. So like a regular electric stove that has the coils, that takes a longer time to heat up and it stays hot for longer. Whereas the induction stove works by sort of electromagnetism, heats up very quickly when you have ferrous cookware. And it also, the heat dissipates very quickly when you turn it off and take the cookware off of that. So there's less of a burn risk. But I think cooking with those two different types of electric is different. I've never cooked on a regular electric cooktop or stove. I do have an induction range and I really like it. So anyway, I don't know if that answers the question.
Bob, good question, and Janet, good question. My understanding is that in under good conditions in each case, the first, going back to first principles, electric is electric. But induction has some advantages that are not necessarily just energy. But the specific question was about energy. On first principles, electric is electric. Other questions?
Okay, Cheryl Goodridge has a question.
This is for Audrey. The first question I have is just to clarify. So I already have air source heat pumps. If network geothermal were to come to my neighborhood, would I be able to use those air source heat pumps?
it's possible that that they could connect in to your air source heat pump, or at least use some of the mechanicals there. It would depend utterly on what kind you have, et cetera. There are now some multi-source heat pumps, which have the ability to do either ground source or air source and switch back and forth depending on which has the highest efficiency at that moment. And what my hope is that the gas utilities go straight down the street, give everybody who has an older heating system a multi-source heat pump, and connect it to the air source outside, right? You'd have a compressor, a little mechanical outside the building. And then once they can finally replace the gas infrastructure on that street, then they interconnect your system to that and take that outside compressor and use it on the next street. And that way, it would be lovely, because then each of us could transition at the point that we have our HVAC began to die, right? And we wouldn't have to make that choice of replacing it with a new gas system or not.
And how can we advocate for your network geothermal installations in our towns or in our areas, or even throughout Massachusetts?
Lovely question, and potentially you can hear my dog making a lot of noise. That's how she does it. She just constantly barks about networked geothermal. But there's the future of clean heat is some
That's a good one.
that would
Not all of us have a dog, though.
that would if you can't, you could possibly teach. No, so future of clean heat is some legislation that would allow gas utilities to transition this way, incentivize them to do so, and pretty much mandate they do it after, that they move towards non-combusting thermal energy at some point, whether it's networked geothermal or not. So that's one possible way. Another way is you can go on the HEET website, and there's a place where you can suggest your street for a networked geothermal install. I can try and find that and put that link in the chat. And you can certainly talk about it with others and mention that this might be a really great way to go, and soon, because we're going to need to do this quickly.
Audrey, can I ask you a question about when the Framingham, oh, I see your dog. Is the Framingham network?
That's my son, actually.
Oh, whoops. Is the Framingham site going to be online like this year, next year? When is it going to go live?
It should happen before, it should go live before the winter season. And
That's amazing.
Isn't it? And theoretically, National Grid's installation in Lowell might also be live by then too. We will keep our fingers crossed. They're moving faster now. It's incredible.
I hope people appreciate just how exciting this both these presentations are. They were first, our speakers tonight first broke this news in each case at a few months ago at the annual NESI conference, and in both cases, terrifically exciting. And just to give a little further context, so Audrey's presentation, where she said, like she just told us, by fall, hopefully, oh boy, the room erupted. All sorts of people said, not possible, not likely. No, it's anyway. So I'm so glad to hear you saying that again, Audrey. And the fact that the groundbreaking happened last week, it was going to be finished by this fall, absolutely incredible. And in terms of Rachel's presentation, again, the context there, folks wouldn't realize is that Rachel's company, Byggmeister, was the premier, is that the way to put it, the champion of deep energy retrofit, and excited the whole building energy field about this 10 or so years ago. They were the leaders. They sort of defined and said it's not only possible, but as Rachel said, the thing. And so for Rachel to come back to the conference this year and say, we decided otherwise, that was incredible. So a significant turnaround and lessons learned. It really took a lot of chutzpah, a lot of guts to come back and present just as the way we saw it today with the facts and the figures. So there's the context and why I was terrifically excited to that they both accepted this invitation. Enough of me talking. Who's the next question?
There's a person whose name is iPad who's got their hand raised.
Oh, that's me. My name is actually Vanita. Thank you both for interesting presentations. Rachel, my question I think is probably more for you. I'm curious why mini splits are so popular. It seems like punching more holes in your wall would be kind of contrary to energy goals. Plus, they're also ugly. So, is there some advantage that I'm missing about them?
That's a great question. Thank you. Okay, so first of all, so at some point in Audrey's presentation, she showed a graph of the efficiencies of different types of heat pumps. So actually an electric baseboard as well. So the most efficient gas boiler or furnace that you can get is like 95% efficient, right? So for every 1 unit of energy that goes into that, once you have the combustion, you get 0.95 at the most, right, out of it. Whereas for heat pumps, for electric baseboard, it's 1 unit in, 1 unit out. So electric baseboard right off the get-go is more efficient at creating usable heat energy than a gas furnace or a gas boiler. Air source heat pumps are 2 to 3 times or 200% or 300% more efficient. So for every 1 unit of energy in, 2 to 3 out. And it goes on from there. Ground source is 4 to 5 times. And Audrey showed some figures that the study out of Colorado Mesa showing that the networked ground source heat pumps are like that have a coefficient of performance. So they're 6 times more efficient. So that's really it's a more efficient mechanism for exchanging heat. And so that's really, I'd say I'd start there. And then of course, if we, as we discussed earlier, sort of moving off of, changing out any way that we're using fossil fuels, cooking, hot water, heating is the biggest. That's the biggest way that we're using. That's like the biggest proportion of our energy use in homes. Moving that to electricity as the grid gets greener, then that is decarbonizing. Now, as for the aesthetics, I hear what you're saying. I've heard that a number of times. I think that you need to think about placement of units, especially when you're doing ductless units, and just sort of slapping them anywhere is maybe a recipe for people to not be happy. You sort of have to think about a combination of where's the best location in terms of distribution, but also what's going to sort of fit with your aesthetic. And there are ways you can do a better job than that, and worse job. And there are also ducted options, which are more expensive than ductless, because if you think about it, you're having to install all this ductwork if you don't have it already. If you already are on a furnace, then you might be able to reuse some of your ductwork. But so there are the ducted option, which the distribution is through sort of do you have hydronic distribution now, or do you have
Forced hot air.
So you know what that looks like.
Yeah.
Right. So, so there are heat pumps that are ducted.
I'm sold on heat pumps based on your presentation and Audrey's. It's more just like, why would you do a mini split as opposed to like central?
Oh, I'm so sorry. I went on and on, and you didn't need me to. I'm sorry. I'm taking up airtime here.
But I think you actually answered my question. It's okay. Like if the ductwork is already there, you can take advantage of it, but if it's not, then it's a trade-off probably, right?
Yes, I would caution you, as Audrey said about sort of it depends on the building and the state of the existing ductwork.
Okay.
And so you, the best case scenario would be you would reuse it as is, but you may need to make some modifications.
Got it. Thank you so much.
Okay.
I'll just add a little kibitz. A ground source heat pump is not visible once it's installed. It's underground, except for the heat exchange unit in the basement, typically.
And let me just say, people keep asking for tours of the networked geothermal, and I feel like you could go down any street and say it's there because you can't see anything. It's really awesome that way.
Cool. Next.
Me?
Is that Scott? Go ahead, Scott.
Hey, very early, Audrey, you showed a table where I know with the Inflation Reduction Act, you know, the big news is 30% every year. But you talked about 40 and 50, and I'm wondering, is that more for the individual homeowner? You're talking about like everybody involved, like the workers, the employers?
So in that case, that's more if you're doing larger installations, if you use basically if you use unions, you know, any sort of fair labor practices. And I think that mostly means that you have to have a bigger installation to do that. And then if you use American made products, then you get up to 50%. And if it's in an EJ area, an environmental justice area, that's how you get 50% tax write-offs.
Do you know if is Framingham one of those?
No, they're not. It does have a lot of low income. I don't know if it's using American made products, and it's certainly not using labor for this union labor for this first install, because it's still more of a boutique industry. And so there is not a lot of, there's no geothermal union yet.
And I think might be next.
Yeah.
Thank you.
Oh, hi, I'm up. Hi.
Yes.
I just wanted to say, wow, what a fabulous presentation. I was, thank you for arranging it, and speakers are great. So thanks so much. But I was curious, Rachel, you talked about in one house, you moved the thermal envelope to the roof as opposed to the attic floor and insulated there. I was just curious, are you doing attics with a ridge vent and a soffit vent and just having the insulation below, or are you always kind of making a hot roof kind of thing if it's not spray?
Well, this is a geeky question.
Yeah, a little bit. Sorry.
It's no, it's good. It's nice to see you, by the way. It's been a long
How are
time.
you?
So, all right. Let's see how to get into this question in a way that isn't going to take us down a total tangent. So, what Anne is asking about is about sort of there are two different approaches. There are code approved approaches to attics. If you can leave them unvented and do a hot roof. If you when you're insulating, you're up against the underside of the sheathing, but then otherwise there's sort of prescription about providing ventilation along the whole underside of the roof. And so I'm not really explaining this very well. I'm trying to avoid getting into too many details. Let me just try to answer the question. So when we insulate at the underside of the roof for an open attic, I showed one example of a house that had an open attic where we have the air handler up there. That was the 2019 project. And what we're doing there, what we did there, and this is our typical approach for open attics, is we start with 3 inches of closed cell spray foam. So we're eliminating the venting at the soffit and the ridge. And that 3 inches of closed cell spray foam is like the minimum what we need, a code required for condensation control in our climate. And then we build down the roof rafters and we dense pack the rest of those behind a smart vapor membrane with cellulose. So that's kind of, if people call that like a flash and fill or approach, but we're trying to minimize our use of spray foam. The other project I showed where we dense packed the finished slopes of a finished attic is actually not a code approved approach. And so, and that has to do with concerns about condensation migrating through the cellulose, and up and to the underside of the ridge. We've worked with Building Science Corporation to develop, and we've gotten stamped. Sometimes we've actually gotten a stamp from an architect to present to the building departments to get that approved. We're using, in some cases, a ridge vent, in other cases, a vapor, what we're calling a vapor port. It's like a vapor permeable membrane in place of the ridge that allows any condensation that makes its way up to the ridge to get out of the top.
Okay.
You can email me separately if you want to get into more detail. Okay.
Everybody there, but
Yeah.
I thought it'd be a quick like hot roof. Yes, no,
No,
but thank you.
you're welcome.
Great. I think Harry's next.
Yes, thank you. This is kind of a follow-up on something I asked earlier in the chat. And I think Audrey is the one who responded in part. But my experience this past year has been that the gas company has been replacing the gas lines in our streets. It's taken them a year. And of course, much of that effort is digging up the road, taking out the old pipes, putting in the new pipes. So my question was, since the gas companies are being obligated in any case to put in new gas lines, why not have them simultaneously put in the geothermal pipes? It seems to me most of the expense and cost is working with the building departments, digging up the roads, replacing the pipes, resealing the roads, etc. Wouldn't that be a great?
Harry, can I clarify? And by the way, we can stay on this for about 15 minutes more. And so whatever Q&A we can do is great. Harry, can I clarify? Are you asking whether while they're doing this work, could the gas utilities add geothermal or replace with geothermal? Which
No,
path do you?
My understanding is they're obligated to replace the old gas lines anyway. And since they're doing that, it seems the incremental cost to install simultaneously the geothermal pipes would be much less than starting that from scratch. And maybe if there were an incentive from the state to go ahead and do that, they would invest and in the long term have a business idea or concept which would continue beyond the. So there's this question about the last grandmother, right?
Mhm.
Obviously, both of those go in parallel simultaneously. It seems like this would be a good solution for everyone.
Yeah, so it's a great question. Thank you. Gas utilities are currently obligated to replace gas infrastructure with gas infrastructure, and they can only sell gas. My hope is that, aside from these pilot installations that they're allowed to do because regulators have approved them, my hope is that, as has already happened in New York and Colorado, that the gas utilities instead are allowed to replace that gas infrastructure with networked geothermal. Because, and having, certainly there's many ways forward into this system, but my hope is that if you, don't have two different competing systems, then you're less likely to head towards that skyrocketing energy bill going forward. That instead they would do like what they did on my street when they replaced, or what they did not do on my street when they replaced the gas infrastructure. Instead of just replacing the gas infrastructure, they would put hangers on every doorknob saying like, we're doing a gas system enhancement. Your gas bill will go down. It'll be safer. You'll get cooling, and we're going to replace your heat pump for free, or your mechanical for free. And they'd come and, rip up the street, replace the gas with networked geothermal, do some work in your home, and keep going down the street. And you would all be, you would be set. Or potentially they'd already replaced your heat pump when your mechanical died a year ago, and they installed that multi-source heat pump, so that all they'd have to do is connect your pre-existing equipment up and take the compressor away. That's what I hope happens, but it could be that this goes forward in many different ways. And it's certainly possible in more suburban areas to have dual infrastructure in the street, but there's just in many urban areas, it's a very compressed real estate in the street. And that's partly why we have utilities, because we can't have a lot of competing infrastructure under the street. We all are supposed to share the same infrastructure, and then each of us pay for a little bit of it. And that's both an equitable method for all of us to be able to access it. And it also means we all don't have to have a cell tower and a water, you know, a well in our backyard and, you know, an electric generator, et cetera. We all just share the infrastructure instead. But it could be that this rolls out in many different ways. So that's just one guess.
I'd like to follow up Harry's question. So what Rachel and Audrey are offering here are what we call sanity. Sane responses to the climate crisis. And John is here, John Brown. I don't know if you can unmute or wave hi. John is part of JCAN's Legs and Regs group. This program is part of our decarbonization work from our tech council, and John is part of the Legs and Regs group. And I mentioned you, John, because Legs and Regs is constantly looking at legislation and regulation that is on the horizon. So what I'm trying to do here is cycle back to Audrey, your first statements, which you didn't use the word sane or insane, but it's a reasonable interpretation. You know, Jews are always reinterpreting. Okay, so I'm going to take a step and reinterpret that. You show us all those holes, all those leaks in the gas system, and you say it's going to cost more than it's worth to fix all those leaks, and it's going to take forever, and we're not going to get any step closer in the meantime to getting rid of gas. So all that is a long way to say we supposedly have a sane leader and some in the Massachusetts State House and the White House. Why aren't these people just saying, Audrey, just tell us what to do? Sorry for the long-winded way of saying that,
Okay.
but you've got a sane approach, and there's got to be sanity in the next 6 years.
So can I just add to that? I think Audrey, what Audrey's talking about, I think the equitable piece is also, I'd just really like to emphasize what I'm talking about is home by home, and there are incentives available for lower income or moderate income homeowners to do the work that needs to be done home by home. But this is really, the path that I'm outlining is not a path that is, you know, when Audrey showed like homes, each of our homes coming off of gas, right? As we, if you follow the path that I've outlined here, and is that I'm getting ready to do on my home, which is I'm going to install heat pumps and I'm going to cut off my gas meter. And so everybody who's left is going to be, you know, until we get to the last grandma. And so we just need, this is what Audrey's talking about, the community approach, the networked approach is the more equitable approach. That's why I think of what I'm telling you and what I'm talking about is really the bridge. I mean, we're going to need to keep fixing our buildings and getting them ready. And electrifying them when you know, with heat pumps as our systems are aging, as we also work on the networked approach. But we need to bring everybody along, and that's going to require that we work at the systems level.
Yeah, exactly. Thank you. Yeah, that we all have to do. I mean, it's such an emergency right now. We have to work incredibly quickly. And so and at the same time, we all have to work together to be able to get a system that will allow us all to transition. And that's constantly inside of me. I don't know about all of you, but I'm like, faster, faster, faster. And at the same time, like, we need to change legislation. We need systems changes to allow us to all get to where we need to go. And that's a really big problem. And in terms of, you know, Governor Healy has just, you know, started. I think there's going to be rapid, incredible changes. I've already seen some of them. And, you know, I think, you know, the IRA from Biden has been just deeply transformative. And I hope it continues. And don't forget, everybody vote.
Audrey and Rachel, can I just ask you to please put your emails in the chat before we're done for folks who want? Harry, are you satisfied with the answers you've heard?
No, I am. I just think that whatever the state can do to incentivize the utility companies to move in the direction they need to move, the better off we'll be. But I understand that I wasn't aware of the fact that the gas companies could, at this point, only provide gas. They can't do the geothermal part. So I guess that's where the laws have to change and convert them to, quote, an energy company rather than a gas company.
Yeah. And I'll just say that anybody else can do it. Like a municipality could install the system, a district energy could do it. Any one of us, if we had enough money and convinced enough people, could do it. But gas utilities are the only ones who cannot legally in a regulated way, which is just crazy.
Wow.
John, is Legs and Regs working on these particular conundrums? You're muted.
We're we're following these and other things, and when we come to something that we can use specific help in getting legislation passed, we pass on the news. And I would love it if we have some specific legislation that will do the things that Audrey was just talking about. So.
But I guess you're saying, Audrey, the governor has not knocked on your door just yet.
We've met with the administration in many different ways, and we continue to do so. And so we offer advice. We'll see how things move forward.
Okay, very politic answer. Got it. Rachel, can you share anything about any feedback you've gotten since the NESE conference with the revelations? Or were people surprised, alarmed, relieved to hear your conclusions about deep energy?
Maybe all of the above, Fred. I think there, we got a number of very particular questions and criticisms that we're hoping to address with some sort of follow-up that answers the questions, I would say. But overall, I think what I think was received really positively was that this sort of the learning curve and the coming back around and sharing. I don't know how much chutzpah necessarily took, but maybe it did. Just coming back around and saying, okay, we used to think this was the solution, and now we think it's not, and here's why. And that, I think, was pretty positively received. Was just the willingness to share that we've changed our minds and why. I think there are a lot of practitioners who don't want to give up on deep energy retrofits for a variety of reasons. I think one of the biggest outstanding questions in my mind is that question about the grid and the need to really rapidly electrify. I mean, of course, buildings are just a small piece. I mean, think of all the transportation infrastructure that we're trying to electrify, and how do we manage that? I mean, this is it's a huge task. But where I keep focusing is I've got to do what I'm doing, which as any chance I get, I do as much as I can to fix a building. And then I say, your systems are, getting near the end of your life, we're going to electrify. And there are other people, I mean, I'm not trying to push off the problem, who are working on the grid and the grid transition. And I don't want to keep me, paralyze me or saying, oh gosh, well, your system's near the end of its life, so I'm going to install a boiler because who knows if the grid's going to be able to handle this additional heat pump. Like I can't think that way.
Yeah, great. And a good argument for, again, very sane, centralized energy planning. Yeah, we all live together. Yeah. And by the way, so while we're all here, how many have EVs? How many drive electric at this point? Raise hand. And how many people are charging only at night?
Mm.
Cheryl, Good for you. But I bring that up because that would be a sane energy policy.
Mhm.
That at least at the residential home level, that we're at least incentivized to charge at night. Cheryl, how do you do it?
We have a plan in town through our DPW that you can get a slightly reduced rate if you sign up for this program and only charge, I think it's between 10 and 7 in the morning or something like that. I mean, it's at night, throughout the night, and it's fine. It's great. I like
And
it.
Cheryl, is that manual, or do you have some little device that turns your car on at that time, the charging on at that time and off by 7 a.m.?
I plug it in and the car's computer does it.
Right. You set it in the car to only charge during those hours. Yeah.
To do that. Yeah.
Thank you. There you go. A little more sanity for all of us. Thank you. Yeah, and the rest of us probably could do that, even though we're not incentivized. We probably should do it. Right. And especially, Rachel, as you're saying, as the masses accumulate, the massive amount of energy accumulates. But yes, the answer that JCAN has been given is we look forward to that becoming a problem on the horizon. It's not even quite on the horizon yet. It's in, the potential, and it's not to be scoffed at, but we have a much further way to go to get enough decarbonization happening for that to be on the horizon. And that, as I think both speakers have emphasized, is our mandate for the next 6 years. So I hope, and if anybody has anything to say about what they're doing in their community at their congregational level to help rally people towards decarbonizing, I'd love to hear it. I hope you all take all these notions back to your community. As I said, let's see, Cheryl, you have, I think, has anybody else here taken the Decarbonizers program, the Decarbonizers training program? So that's something to look forward to. I encourage you all to sign up next time it comes around to a little training for how to take these ideas back to help organize within your community so that all your co-congregants become decarbonizers. And when are you going to print the flyers, Audrey, that we take just to hand out down the street?
Yeah. We do it all by our phones now, right? So.
But seriously, and this is, I don't mean to provoke, but you may have answered this a couple of different ways already, but so Framingham, let's say a year from now, we reconvene. Framingham is up and running and it's had a good winter, whatever. Cold.
And Lowell is up and running, and potentially one in Merrimack Valley, and
Great.
a whole bunch in New York, possibly by then. We have a research team with 2 national labs, MIT and others. And we hope to be getting, we already have the data so far from, benchmarking the thermal, temperature in the ground, et cetera. We hope to be able to share within a year the beginning of the results of all of that, where a lot of academics are putting pressure on this idea and figuring out how to scale it, what the impacts will be, and where to go from here, where it's financially viable.
Great. Okay, so I guess that's the next program. I was gonna push you for to tell us what the next step is, because everybody wants it in their neighborhood. But I guess you're saying we have to wait for the results, the analysis.
Well, yeah, request a networked geothermal on that. I put the link in the chat in your neighborhood, like make this a popular movement forward. Call up your legislator and mention that this is, the future of clean heat. Talk to your gas utility and say that this is the way we should go. Many other things. And let's hope within a year we've got a lot of progress.
Great. Well, this is the Jewish Climate Action Network, and we want to see ACTION action, action, action. So if you've got, in the meantime, Audrey, if you've got good ideas for our legs and regs, John wants to hear from you. about legislation. And I hope people are motivated to do what can be done now, a la Rachel's outline. And I'll just make one more plug. Rachel has, I think you still do this, Rachel, or you can tell me, that you help households, homeowners, make a plan so they can do something today and plan for the next step down the road and the next step after that, but so that the one thing doesn't interfere with the next.
You got it. You could be my sidekick, Fred.
I heard you make that presentation. What is it now? 7 years ago, and it's.
I don't know.
It's like, oh wow, that's so brilliant. Okay, so it's after 8:30. I'll stay on for a couple more minutes, but any last words for our speakers? I thank you very much, Rachel. I thank you very much, Audrey. This has been a fantastic program.